Welcome in 6th grade. Today we're going to be taking a look at Eureka Module 2, Lesson 3 in your Eureka workbook. And to start this lesson, in the opening exercise, it's going to ask you to draw a model that represents 12 divided by 3 and to create a question or word problem that matches your model. I think it might be better if you make a story up first. So you may want to come down here and do this part first and think of a creative situation that would match this problem right here. So take a few minutes, reflect on what you've learned about word problems in math, and try to match up a word problem for 12 divided by 3. All right, so we're back. Those were all some great examples. Y'all have some wonderful ideas. I really like the one about the egg carton, but I wanted to share my idea with you here. So in my example, I created a story where me, my brother, and my sister share a 12-slice pizza. And I like this story a lot because if you ever get a pizza, make a little drawing of a pizza here, you'll see most of the time, not all the time, but most of the time, that pizza is going to be cut into 12 slices. Just like this right here, you can count them. You trust me, believe me, there's 12 slices right here. See, there you go, 12 slices, all counted out right there. All right, so we got me, my brother, and my sister, and I'm just going to start handing out pieces. So I get the first one, say my brother gets the second one, and then my sister gets the third one. So we cross that one out. So we each have one right now. All right, but we still got more pizza right here, so let's keep going. I'm going to get the next piece. My brother gets another piece. My sister gets another piece. All those pieces are gone. Well, look, we still have pizza left, so we continue onward here, and you can see where this is going. We're all going to wind up with approximately 4 pieces of pizza. Or should I say exactly 4 pieces? For most of you who know your math facts, this doesn't blow your mind. You know that 12 divided by 3 equals 4. This may have been the way you thought about your visual model as well. And this is called partitive division, where you have parts of the whole pizza here in this example that you handed out, so you partitioned to individuals. And this is also how I initially envisioned this problem. I have 12 parts of a whole, and I need to separate them into 3 groups between 3 people. So that's my thinking. I have 12 parts, 3 groups. How many parts does each group get? 4. Another way you may have thought about this is that you have a 12-part something. In this example, again, I'm using my pizza, and you want to split this into groups of 3. So we would take these slices right here, and we would hand them out, and then these 3 slices, and then these 3 slices, and then these 3 slices. Well, how many groups of 3 will you have? Well, we have 1, 2, 3, 4. And this way of thinking is called measurement division. And whether you thought about this as partitive division or measurement division, you should come out with the same answer. 12 divided by 3 equals 4. Now, before you move down your workbook page to example 1, I want you to consider these problems right here. So take a minute and see if you can find some solutions. Get out a scratch sheet of paper, or you should have room on the side of your paper to do this. Or you can get a marker and do it on the table if you're in my classroom. Take a minute and find some solutions to these problems. We have 8 divided by 2. Well, I know my basic math facts, and 8 divided by 2 is 4. Just dividing 8 by 2, right? We can go back and do a visual example of this, but the 8 divided by 2 is 4. Great. But what happens when we add the units behind them? So what's 8 ones divided by 2 ones? Well, did this even change anything from the first problem? Not really. 8 ones and 2 ones are the same as 8 and 2. So 8 ones divided by 2 ones, also going to be 4. So they had similar units behind them, when we divided, those units essentially disappeared. All right, so what do you think is going to happen when we divide 8 tens by 2 tens? Well, what is 8 tens? 8 tens is really just 80. 2 tens is really just 20. What happens when we divide 80 by 20? Well, based on what we're doing here, the units behind them are going to disappear, and we're just going to be dividing 8 by 2, which is going to get us 4. Now, before you start questioning me, let's go and double check that. I got my calculator. Oh, I'm cheating. I got my calculator out. I'm going to check and see. 80 divided by 20. I'm just going to double check my math here. Oh, wait, it is in fact 4. So here again, they had similar units behind the numeral. So those units disappeared when we divided. We go down. What do you think is going to happen right here? They both have the same units. Those units are going to disappear. 8 divided by 2 is 4. We'll double check just to prove that this is the case. 8,000 divided by 2,000. What do you think we're going to get? Oh, wow. Okay. All right. So this pattern is working. So when the unit behind them are the same, dividing is pretty simple. You can just take the numeral in the front. All right. So let's go to this next one. What about 8 tenths? 2 tenths. What does that even mean? What are tenths? Well, those are fractions. Those are fractions of a whole, right? If we wanted to write this as a decimal, 8 tenths would be 0.8, since one place behind the decimal represents the tenths place. So we have 0.8 divided by 0.2, 2 tenths, which is going to happen the same way that it happened with the 8 tens and the 8,000s. We just take away the unit price, the unit piece here, and we have 8 divided by 2, which is going to get us 4. Now, hold up, Mr. Shane. There's no way that that's going to be true. If you put that in the calculator, there's no way it's going to come out to be 4. 8 tenths divided by 2. Oh, what? Oh, well, look at that. It sure happens to be. It's not 4 tenths. It's just 4. The tenths, since the units are similar, they are factored out when we divide. So we come down to 8 thirds divided by 2 thirds. Well, these units are the same, so when we divide them, they're factored out. And we're left with 8 divided by 2, which is going to give us 4. So what we have found here is something of a shortcut for dividing fractions with similar denominators. Because take a look at a problem like this, maybe you start freaking out a little bit, but if you see that they have common denominators, in this case they do, then we can just divide the numerators, which is pretty simple for 8 and 2. 8 divided by 2 is 4. All right, so now that we have a little cheat code here, let's go back to our example 1. And we see we have 8 ninths divided by 2 ninths. Well, we already kind of learned a little cheat code here, didn't we? We know that since they share the same unit, they share the same denominator. We kind of ignore that and just divide the numerators. 8 divided by 2 is 4. Mr. Shaheen, this next part is asking us to draw a model to solve. How am I going to model 8 ninths and 2 ninths? That's a great question. So first of all, let's model 8 ninths, our base amount here. So let's draw first, just as an example, let's draw a little bar right here. And this bar is going to represent 1 whole. So this is 1. But we need to break this into ninths. So we're going to partition this. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. So now you see we have equal parts 1, 2, 3, 4, 5, 6, 7, 8, 9. So now this whole is broke up into 9 individual parts. 9 ninths of this whole. So 8 ninths represents this portion right here. And just for the sake of illustration, I'm going to mark out this 9 ninths. This part right here was part of the whole, but it's not part of the It's not part of our dividend, the part that we are trying to divide up. 8/9 is our dividend. So we have 8/9 right here. But we want to, and we need to think back to our measurement division, right? So we're dividing this by 2/9. So we want to break these up into groups of 2/9. We want to break up this 8/9, 8/9 right here, into groups of 2/9. So right here, I have one group of 2/9. I'll circle it right here. That's one group. Well, we still have more 2/9, right? So I have another 2/9 right here. That's the second group. Our third group of 2/9. And then look, we have one 2/9 group left. So when we divide 8/9 into groups of 2/9, how many groups do we have? Well, we have 1, 2, 3, 4 groups of 2/9. The reason I wanted to bring this back to measurement division was because for me, and I know probably some of you, you want to think about this as partitive division, the way we did before with the pizza where we had the 12 parts and we broke them up. But when you think about having 8/9 of something, okay, well, I have 8/9 of what? And then I want to separate that into 2/9 groups. What? Well, I couldn't do that. But I can take 8/9, my dividend, and separate it into individual groups of 2/9, which I did here. And so in this way, in this example, the measurement division was easier to kind of think about than partitive division, even though you, and I know certainly I am more familiar with partitive division, where you have a number of things and you have to separate them into a number of peoples or groups or whatever. And so each group has a whole number of groups. In this case, we're dividing something into groups that isn't a whole number. So it's a little bit more confusing. But when you think about it using measurement division like this, maybe it clears things up a little bit. Hold on, Mr. Sheen. Let's go back here. Rewind, because this problem right here, it also asks us to write in expression, the expression in unit form. What is unit form, Mr. Shaheen? Oh, okay. Well, let's think back to what we did on our scratch sheet paper that I have right here. And this right here is what unit form is. Okay? 8 ones. Ones is the unit. That is your unit form. So let's go back. They want us to write 8/9 in unit form. Well, we're going to write that as 8/9 divided by 2/9, which will equal 4. So there you go. You have a model version up here and the unit form down here. All right. So now I want you to take some time and we're going to move down to the next problem. And I'm going to give you some time to work through example 2, 3 independently. So examples 2 and 3 independently. Let's go. You got some time on the clock. All right, we're back. All right, so y'all have seen in example 1 in here how to work some problems like this right here. So examples 2 and 3 are very similar. We're dividing fractions with common denominators. Here you can see the denominators in both of these, 12. All right, so if we're working this out, we know that we can pretend for a minute like these guys don't even exist and just divide 9 by 3. Well, some of you may already know 9 divided by 3 happens to equal 3. But they want us to draw a model of this, right? So let's model it out. So we're going to have 9 12. So we're going to take a whole, just like we did in our first example. We'll take a whole, and we're separated into 12 parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And all of those are equal, as you can see, perfectly equal, as that is how I draw. I can draw perfectly even portions of the whole here. So again, the whole stick represents one whole, or 12 twelfths, right? 12 parts of 12 pieces, one whole, okay? All right, but we need the dividend. We only need 9 twelfths of this. So just to illustrate, this portion right here is going to be 9 twelfths. And just for the sake of the illustration, we're going to make these parts disappear right here. They're irrelevant to this part of the problem. Now, we want to separate this 9 twelfths section of the whole into 3 twelfths parts. So each part is going to get 3 twelfths. Well, this is one. It's 1 3 twelfths. There's 3 right there. 1, 2, 3. There's another 3 twelfths right there. And then one last 3 twelfths, which in this example, there doesn't happen to be any remainder. There doesn't happen to be any left over, right? So how many groups did we have? We had one group of 3 twelfths, 2 groups of 3 twelfths, 3 groups 3 twelfths. So 9 twelfths, as we illustrated, divided by 3 twelfths, leaves us with 3 groups of 3 twelfths. Fantastic. Okay, and they want us to write this in unit form. We did that earlier. Remember, we just write it out, right? 9 twelfths. And that is how you spell twelfths. That is correct. Divided by 3 twelfths. Well, 12 twelfths. That looks great. And it's going to equal tree. Yeah. And that's a beautiful thing. So you have the illustration up here, the uniform down here. Great. I really liked the one that you drew. You went back and did the pizza like we did last time. That's wonderful. I love that. I appreciate that. That's great. This is also a fine example. Let's move on to example 3. Again, we have fractions that we're dividing with similar denominators. So we already know that we can kind of ignore them. They're going to factor out when we divide 7 by 3. Uh-oh, though, we can't divide 7 by 3 perfectly, can we? So what's going to happen right here? Well, let's start by illustrating. So we have our dividend right here, 7/9. So we're going to take the whole again. We're going to make our bar right here. It's going to be the whole, and we're going to separate it 1, 2, 3, 4, 5, 6, 7, 8. So that's 9 pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9 ninths. And we're only going to need 7 ninths of that. So we're going to borrow that. We have 7 ninths right here. And we want to separate it into groups of 3 ninths. So let's start doing that. So we separate one group of 3 ninths. Well, that's one whole group right there. That's great. We're on the right track. Okay. Then we have 2 whole groups of 3 ninths. But then what do we have left over? Well, here we do have another group of 3 ninths, but remember, these right here aren't part of our dividend, right? 7 ninths is our dividend. So what do we have left over here? We have just one part of this group. One of 1, 2, 3 parts. So we have 1/3 left over. So what is our answer then? So what's 7 divided by 3? Well, it's 2 whole groups with 1/3 left over. So we want to write this in uniform now. And again, we'll have 7 ninths divided by 3 ninths. So I wrote that, which gets us 2 and 1/3. Now another way you might have thought about this, going back to using our cheat code, we have 7 ninths divided by 3 ninths Well, they have common denominators, so we can ignore them. So really what we have is 7 divided by 3. Well, we know that 7 divided by 3 can also be written as a fraction. 7 over 3. 7 divided by 3. So, divide 7 by 3, we get 7/3. We can simplify this. This is called an improper fraction. So we look and we see how many times can 3 go into 7. Well, it can go into 7 twice, right? Because 3 times 2 equals 6, right? So we have 6 taken out, and how much do we have left over? So we subtract 7 minus 6 equals 1. That means we're left with 1/3. You may have had teachers in the past that when you have an improper fraction like this where the numerator is bigger than the denominator, that they would request that you turn this into a mixed number. They would rather see this as 2 and 1/3. Now what I'm telling you is that I will accept either one of these. 7/3 is equal to 2 and 1/3. So if you want to save yourself a step, in Mr. Shaheen's class, I will accept 7/3 rather than 2 and 1/3. While we need to understand how to go from 7/3 to 2 and 1/3, as far as I'm concerned, when you're writing a solution, either one of these answers is acceptable. So it's really up to you. Are you a stickler for improper fractions? Do you demand that they turn into mixed numbers? Then do it. Go ahead. That's probably what you were taught for a long time, and that's fine. As far as I'm concerned, 7/3, save yourself a step. 7/9 divided by 3/9 could just be written as 7/3. All right, let's move on to these exercises 1 through 6. All right, and I wanted to start with exercise 1 together. We'll maybe take a minute. You can maybe try to figure this out on your own. Okay, we're back. Okay, so in exercise 1, they ask how many fourths are in 3/4. All right, so let me ask you a question. How many fourths are in a fourth? How many 1/4ths are in a fourth? If you answered 1, that's correct. Now, how many 1/4ths are in 3/4? Did you say that there are 3 1/4ths in 3/4? Then you are correct. Fantastic, great work. So I want you to go and do problems, exercises 2 through 5 independently, and you'll see that all of these, as you're going down, they're all fractions that we're dividing, and they all have similar denominators. So you can use the cheat code that we had used in previous examples to come up with your solutions. So take some time. You pause the video right here. Just go ahead. Okay, we're back. All right, so we want to divide 4/5 by 2/5. Well, there's a number of ways we can do this. Now, in this part, I'm not asking you to make a model. Okay, so we can go ahead and just kind of use our little trick right here. We know that the 5's will factor out since they're similar denominators, so we can just divide 4 by 2. Well, if you know your math facts, 4 divided by 2, that's going to be 2. Great, fantastic. Let's keep it moving. Maybe you drew a model. That's beautiful. I love that. I appreciate your extra work. Okay, then we have 9/4 divided by 3/4. Well, again, we can ignore the denominators because they are common. If they were not common denominators, we could not do this. But since they are common denominators, they will factor out when we divide. So we just divide the numerators. 9 divided by 3 equals 3. All right, so right here we have a similar example to example 3 that we did previously. They have common denominators again, 8 and 8, but we have 7 divided by 2. Well, some of y'all may know that 2 doesn't go into 7 evenly. So what we're going to do is we're going to write this as a fraction. 7 over 2. 7 divided by 2. Remember that a fraction is just another way to write a division problem. So 7 divided by 2 is 7 halves. That's a fair way to write that. Now, if you wanted to, if you did this extra step, that's great. We also know that 7 halves is equal to 3 and 1/2. 2 goes into 7 3 times with the remainder of 1. 1/2, I should say. Great. So you can have either 7 halves or 3 and 1/2. Either one of these answers will suffice right here. All right, moving on to questions 5 and 6. Once again, common denominators. So as we've done in the past, we can factor them out and ignore them and just work with our numerators, which are right here in the screen view. 13 divided by 2 will be 13 over 2. Again, Mr. Shaheen thinks this is a fine answer. I'm not going to ask you to do more, but if you wanted to, 2 goes into 13 6 whole times. 6 times 2 is 12, which means you have a remainder of 1. 1/2, 6 and 1/2. So 13 halves or 6 and 1/2. Either one of those answers is correct. All right, number 6. One more time. Common denominators, we can ignore them and just divide our numerators. 11 divided by 3 is just 11/3. And that's a fact. 11 divided by 3 equals 11/3. That's an answer. That's a fine answer. Or we can continue and turn this improper fraction into a mixed number. 3 goes into 11 3 whole times, which will get us 9. 11 minus 9 means we have 2 remainder, 2/3 as a remainder. So our answer here could be 11/3 or 3 and 2/3. Fantastic. Great. Okay, so with that, we're done with the classwork. And from here, you're going to be working the problem set for homework. You are going to be given the rest of the time in class to work on this. 1 through 7 here, as you can see, are just division problems. There's nothing else to them. You solve them just like we worked the problems before. Remember, you can leave those answers in mixed numbers or as improper fractions, whichever you like better. And then 8 through 11, make sure you check your rubric for how to respond to constructive response questions. All these are constructive response questions. Thank you for your time today. Y'all have a good one, and I'll see y'all in the next class, I guess.